Bismillahirrahmanirrahim. In this lecture, we will discuss about the modified version of the Euler's method, and it is known as modified Euler's method. Okay, modified Euler's method. Modified Euler's method. Okay. So before that, in Euler's method, you know that how we are getting the solution. Actually, suppose we are having a point initial value at some point, that is x naught, we have the value y naught. Now according to the differential equation, that means dy by dx, which is equal to f of x comma y, we will be finding, actually we want to approximate the curve which is passing through this point, and the slope of the curve is nothing but f of xy, because f of xy will give you the slope of the curve. Okay, so the slope of the curve which is passing through the point x naught y naught will be f of x naught y naught. So there will be some curve, actually there is some curve which is passing through this point, and the slope of this curve was f of x naught y naught, because it is directly giving directly obtained from the differential equation. Now we are approximating, suppose we are having the curve, actual curve, something like this. This was our actual curve. Okay, now whatever we have approximated will be something, it will give you some point somewhere here, and this may be your x1, and according to that you will be calculating y1. Okay, but the actual y1 is somewhere here, right? Because according to this x1, this is your actual one, because this is the actual y1. So you can see that there is some error in the Euler's method. In order to avoid this error, you can say how much it is the error. You can say this much is the error. You can say this is the error in approximation. Okay, approximation using the Euler's method. Okay, so in order to avoid this error in the approximation, we are using something known as the modified Euler's method. Okay, so that I will discuss. So in modified Euler's method, let us consider the same problem. Let us consider we are having the x-axis, and this is y-axis, y of x, and we have the initial value which is x naught, and we have something known as y naught, and the differential equation is also given, which is nothing but dy by dx is f of x and y. So as I told previously, that there is a curve which is passing through this point. Okay, and there may be the exact curve may be something like this. This is your true curve, actual curve, which may be something like this. This is your actual curve. So this is the actual curve, and you want to find this curve. You want to find this curve, actual curve. Okay, now you have the initial point x naught and y naught, because x naught and y naught is given. Okay, now we are approximating the curve, the neighborhood of this x naught y naught, with a straight line in Euler's method. Okay, now suppose we have the new point, let's say the new point we have x1, and you know that by using the Euler's method, what we have done, we have approximated for this particular x1, we have found what is this delta y, and this is y naught, and we found this is y1, which is nothing but y1 plus delta y, and it was approximated like this, right? This is y naught plus delta y, that means y naught plus h into f of x naught and y naught, right? F of x naught y naught. This was the technique that we have used in the Euler's method. You can see that there is a large error here. Actual solution is somewhere here and you are getting a solution somewhere here. So what we will do, we will find the slope of the curve by using this x1 and y1. That means by using our x1 and y1, okay, we will calculate the slope of the curve at x1 and our y1. Okay, so we will calculate the slope of the curve. So you may get something like this. If you calculate the slope of the curve at x1 y1, you can say that you will get something like this. So you can see here, this was your curve and you are getting something like this. So you will be taking the average of this. So the average of this, you can see that one curve is passing like this and one is like this. The average may be coming in between, right? So you will find the average of these two slope. So you can say that you will find the average of these two slope like this. So you will find the average of these two slope. So you may get something like this, a slope something like this. So this was the slope, at x0, y0, and this is the slope that you have got. This is the slope that you have got. Can say, I will show with a different color. This was the slope at x1 and y1, but this y1 is obtained by using Euler's method. Okay, not modified Euler's method. That y1 has been obtained by using Euler's method. Now you can see, now you are taking the average of this. So what is this? You can say this is the new curve. This new curve is the average. Okay, this is the average of two slopes. Okay, so you can approximate with some other line with another slope. So this point is, now if you are using this curve, if you are using this particular curve, if you use this curve, you can see that you can approximate somewhere here and it is more close to the solution. So you can reduce the error by using modified Euler's method. So we will use some special notation. Now I told you we will start with x0 and y0, and by using x0 we will calculate x1, and by using x1 we will calculate y1 by using Euler's method. We will calculate this y1 by using Euler's method. And what is this y1? The y1 which is obtained using Euler's method, we will notate it as y1 m. Okay, we will notate it as y1 and m. Okay, now after obtaining this y1 m, you will be finding the slope at x1 and y1 m. Okay, then you will be finding the average of the slope and it is used to approximate the solution. So at first it has been given x0 and y0. Okay, now you will find your the y1 of m. y1 of m means you will find your y1. Okay, you can say that you will find your y1 by using the Euler's method. How to find y1 using Euler's method? That you have already studied. y0 plus h into f of x0 y0. So this y1 we will call it as y1 of m. We will call it as y1 of m. Now we have the slope. Okay, I will use the next page. So we have something like this. So we have x naught and y naught, which is given, and you know the slope at x naught and y naught, slope at this point x naught and y naught, slope at x naught y naught is known, which is nothing but f of x naught y naught, because this is nothing but dy by dx. Dy by dx is nothing but the slope of the curve. Now you have you will find y1. How to find y1? By using Euler's method. Okay, by using Euler's method you will find y1, which is nothing but y naught plus h into f of x naught y naught, that you know, and we will call this y1 as y1 of m, y1 of m. Okay, or you can say y1 of 0 or y1 of m, anything. Okay, y1 of m. Now you will find now you have now you have x1. What is x1? x1 is equal to x naught plus h, and also y1 using Euler's method, which is y1 of m, which is nothing but y naught plus h into f of x naught y naught, right? This is what we have the information. So now that means you have new points x1 and y1 of m. And what is this y1 of m? y1 of m is obtained by using Euler's method. Okay, now we will find the average of this slope, average of these slopes. How to find the average of the slope? You can see here I have shown in the, you can see here, this is the first slope, and this is the slope at the second point, and this is nothing but the average. Okay, so the average is more close to the will give you a good approximation to the slope, because the slope of the curve is changing actually according to the function. So the average of the slope is nothing but you can say the average is, what is the slope? Slope is slope at x naught y naught, you know, right? So it is nothing but x naught y naught plus slope at x1 and your new point y1 of m. Okay, and you will divide it by 2. So this is the average of the slope. Now the modified Euler's method will use the average slope. Okay, average slope. That means you can get y1, your actual y1, you can say it is you will get your actual y1 as something like this. y1 is equal to y naught plus h into this average slope. This is the average slope, which is nothing but f of x naught y naught plus f of x1 y1 m divided by 2. Okay, or I can write in this way also. That means it is h over 2 n2. So this is known as the modified Euler's method. Okay, I hope that this is clear. After doing a problem, it will be more clear to you. So now we will see a problem. Use modified Euler's method to solve the differential equation dy by dx is equal to x plus y square, okay, with y0 equal to 1, okay. Obtain the solution for y of 0.1 and y of 0.2 with a step size of h is equal to 0.1, okay. So the differential equation is given, so we are going to solve this. So you know that dy by dx is given, dy by dx is equal to x plus y square, okay. This is nothing but your f of x comma y, and it is given that y of 0 equal to 1, that means x0 equal to 0 and y0 equal to 1. So these are all given, okay. This is given and the differential equation is also given, and you need to find. Now the step size is given, h is equal to 0.1, this is also given. Now we need to obtain the solution, okay. We need to obtain the solution. At first we will use the Euler's method to find the x1 and y1 m. So we use the Euler's method at first, okay, as the first step. We will get x1 is equal to x0 plus h. What is x0? X0 is nothing but 0 plus 0.1, which is equal to 0.1. So we got x1. Now what is y1? And that means y1 is equal to y0 plus h into f of x0 y0. This you have already seen, and this y1 we will name it as y1 of m, okay, because it is not the final solution, okay. So we are using another kind of notation for representing this. So what is y0? Y0 is given, which is 1, plus what is h? H is equal to 0.1 into f of x0 y0. You see here the function is given x plus, so x0, what is x0? X0 is equal to 0 plus y0. What is y0? Y0 is equal to 1, that means 1 square, right? So this is equal to 1 plus 0.1 into 1, which is equal to 1.1. So you got y1 of m. Now you can find the solution by using modified Euler's method, okay. Modified Euler's method solution. How to find it? It is nothing but y1 is equal to y0 plus, it is nothing but y0 plus h into f of x0 y0, h by 2 into f of x0 y0 plus f of x1 y1 m, okay, because we are taking the average of the slope. This is the point at x0 and y0, and this is at x1 and y1 m. So we are taking the slope, you can see here at x0 and y0 we have a slope, and at x1 and our approximated y1, that means somewhere here at the approximated x1 and the approximated y1, at approximated y1 we have another slope, and we are going to take the average of this slope, okay. We are going to take the average of this slope, maybe somewhere here, and we will use this slope. This is the average, as I have told in the uh, told before. Okay, now we will find y1. We will find y1. What is y1? Y1 is equal to y0 plus, I will write it again, h by 2 into f of x0 y0 plus f of x1 y1 m, right? And our f of xy is nothing but x plus y square. You have to note this, okay? X plus y square. Now what is y0? And it is given also y of 0 equal to 1, okay? So y0 is equal to, we have y0 is equal to 1 plus h is equal to 0.1 divided by 2 into f of x0 y0. Okay, f of x0 y0, we will calculate f of x0 y0 anyway. So we will calculate this first. Okay, f of x0 y0. What is f of x0 y0? That means x0 is equal to 0 and y0 equal to 1. That means 0 plus 1 square, which is equal to 1. Then f of x1 y1 m, which is equal to, x1 is, we have already find it, x1, we have already got x1, this is our x1, so x1 is 0.1 plus what is our y1, which is obtained using Euler's method, it is nothing but 1.1. So 1.1 the whole square. Okay, so 1.1 the whole square. So you will get something like, let me calculate this. So 1.1 square, you know that it is 1.21, then 1.21 plus this become 1.31. Okay, now you can calculate y1. Y1 is nothing but, so y1 is equal to y0 plus y0 is equal to 1 plus 0.1 over 2 into this f of x0 y0 is 1. Okay, 1 plus this is 1.31. Okay, so 2.31 divided by 2 into 0.1 plus 1, that is equal to 1.1155. So this is the answer. So what is this y1? Y1 means y of, y1 means what? Y1 is y of x1. What is x1? That is nothing but y of 0.1. So you got y of 0.1. Okay, so this is nothing but y of 0.1. So you got y of 0.1. Now you have to find y of 0.2. Okay, so you will proceed in the same way. So if you want to calculate y2, so using the modified Euler's method, so by using the Euler's method you will calculate y2m. Okay, y2m is nothing but y1 plus h into f of x1 y1, right? Isn't it? So what is f of x1 y1? Which is nothing but x1 is 0.1, so the function is x plus y square, so 0.1 plus y1. What is y1? Y1 is 1.1155 whole square. Okay, so you will get it as 1.3443. Okay, so you will get this answer. Now y2m is equal to, y1 is 1.1155 plus 0.1. Okay, so sorry, this is not, okay, sorry, this, okay, now 0.1, h is 0.1, this is nothing but the h. Okay, 0.1 into 1.3443. Okay, So you will get it as 1.3, let me calculate this, 1.3443 into 0.1 plus 1 point. So this you will get it as 1.2499. Okay, you will get it as 1.2499. So this is Y2M. Now so you will get this as 1.2499. Now you can calculate by using modified Euler's method, by applying the formula for modified Euler's method. You can calculate Y2, that means Y2 equal to Y2M plus H by 2 into F of Y2M Y2M is equal to sorry, this is not like that, this Y1 plus H by 2 into F of X1 Y1 plus F of X2 Y2M. Okay, so you have all these details. I will write it. Y1 is equal to, you know this, y1 is equal to 1.1155, 1.1155. Now you know f of x1 y1, this is nothing but, you have the function, what is x1? X1 is equal to 0 plus 0.1, that means 0.1. So that means 0.1 plus y square. What is y1? Y1 is 1.115 the whole square. Okay, so you have already calculated it. It is nothing but 1.3433. okay, 1.3433. so this is nothing but 1.3433. okay, this you have already calculated. Now f of x2 y2m. What is x2? X2 is nothing but, you know this x2. What is x2? X2 is equal to x1 plus h, which is nothing but 0.1 plus 0.1, which is equal to 0.2. So f of x2 y2m is nothing but 0.2 plus y2m. y2m, you know this, y2m, this is y2m, 1.2499, 1.2499 square. Okay, so let me calculate this. 1.2499 square plus 0.2, this is nothing but 1.7622. okay, now you can use this formula for modified Euler's method. okay, you can use this formula. y2 is equal to, y1 is 1.1155, this is your y1, plus h is equal to 0.1 over 2 into f of x1 y1, you already know this is 1.3433 plus 1.7622. okay, so let me calculate this. 1.7622 plus 1.3433, this is equal to, answer is equal to 1.270775. okay, so this is the answer. And what do you mean by this y2? y2 means y of x2, it's nothing but y of 0.2. so according to the question, you can see we want to find y of 0.1 and y of 0.2. so in this way you can proceed to get the answer. So we got the answer as y1, which is nothing but y of 0.1, is equal to 1.115, 1.1155, and y2 is equal to y of 0.2, which is equal to 1.270775. Okay, so this is about the modified Euler's method. So what you have to be what you have to note is that in Euler's method, by using in modified Euler's method, you will first find the new value, that means the new value of x1 and y1 by using x0 and y0. After that, you will find the slope at x1 and y1, and also you have the slope at x0 and y0. Okay, that means your current point. So by using the current point and the next point, okay, how to get the next point? Next point is obtained by using your normal usual Euler's method. Okay, so by using the current point and the next point, you will calculate the average slope. That means by using the current point, okay, and the next point, how to obtain the next point? Obtain using Euler's method. So you will use the slope, slope at next point. Also you will use the slope at the current point. After that, what you will do, you will add it and divide it by 2. Okay, so this is nothing but your average slope. Okay, and by using this average slope, you will update. And what is the equation for updating? In general, you can say that your yn plus 1 is equal to yn plus h by 2 into f of xn yn, okay, plus f of xn plus 1 yn plus 1. How to obtain this yn plus 1? We will call this as yn plus 1m. How to obtain this? By using Euler's method. Okay, so you are taking the average of the slope, okay, and how to obtain this yn plus 1 of m? It is nothing but yn plus h into f of xn yn. And what is this? This is nothing but the Euler's method, and this is the formula for modified Euler's method. I hope that this is clear to you. Thank you.